So what are we doing today? We're going to be able to write a biconditional and recognize a good definition. How are we going to do this? We're going to examine the statement as well as its converse to see whether or not what we have is actually true, just like we were talking about on Monday. And why are we doing this? It's because definitions are difficult. Especially when it comes to more complex definitions, it's really hard to write a good definition. So we want to make sure that we practice this skill so that we get good at it. So let's begin with a definition here. What is a biconditional statement? A biconditional statement takes just the conditional statement and its converse, and it sort of just combines them into one. So consider this example here. This is the biconditional, but let's actually break it down and talk about what it is. So if a point is a midpoint, then it divides a segment into two congruent segments. So that's the statement. And then its converse, we flip it around. If a point divides a segment into two congruent segments, then it is a midpoint. And you go through and you look and you say, all right, well, is the statement true? Well, if a point is a midpoint, then well, that's what a midpoint does, right? The midpoint divides a segment into two congruent segments. If a point divides a segment into two congruent segments, then it's a midpoint. Well, isn't that what the midpoint is? The thing that divides a segment into two congruent segments, that's the midpoint. So the statement is true. Its converse is true. So we are allowed to write it as a biconditional, a statement that goes both ways. It's like a two-way street. It works both ways. Biconditional, bi for two. And so this is the way we'd write it. We dispense with the if and the then. We take, here's our A. Here's our B, our P and our Q, our hypothesis and conclusion. And we connect them in the middle with the phrase if and only if. That is to say, this works if this is true, but not just if this is true, but only if this is true. It works, and it's the only time it works. These two things are codependent on each other. The only way that each of them work together is if they're both there together. So when we have some examples of how to write it, this double-ended arrow is very commonly used, especially when you get to higher levels. You see this double-ended arrow all the time. You can also write it out with the phrase if and only if in the center. Now, I'm not saying you have to do this, but when I was your age, they taught me that you can abbreviate if and only if as IFF. So this means if and only if. It's just an abbreviation. If you don't want to write the the 11 letters that if and only if is, and you're like, I don't want that's like 8 too many letters. I don't want to write 11. Well, here you can do IFF, and it means the same thing, right? So all of these different ways are totally valid. If you wanna write it out with the double-ended arrow, sure. If you want to write out if and only if in the middle, also fine. If and only if that's too many letters, you can always do just IFF, and I will know that you mean if and only if. People ask, well, why is it IFF? Why does that act as the abbreviation for this? I don't know. That's just what somebody decided. Your guess is as good as mine. But so basically, that's what we're doing. If we have a biconditional written, we can split it up into its two if-then statements, the statement itself and then its converse. If we have the two, then we can glue them together, take out the if and the then, and then put if and only if in the middle. So let's look. I want to write a biconditional. So what they're asking me to do here with this problem is write the converse of whatever this statement is. And if the converse is also true, then we can rewrite it as a biconditional. So let's do that. Here's our sentence. If the sum of the measures of two angles is 180, then the two angles are supplementary. Okay, that's true. That's what we know. Two angles adding up to 180 means that they're supplementary. So let's look at the converse. If two angles are supplementary, then their measures sum to 180 degrees. And we look at that, okay, two angles supplementary, what does that mean? That means, as we've been taught from when we were little kids, that the measures add up to 180. So this is also true. Check, check. They're both true. So now we can write it as a biconditional. So remember, what we're going to do is we're going to get rid of the if and the then, and we're going to put instead in the middle if and only if. And obviously, look at what you're writing. If it turns out that what you're writing doesn't sound right, you can add a couple words here and there to sort of massage it so that it works and it sounds good. Your goal is to make it sound not like a caveman did it. So again, we're getting rid of the if. So we say the sum of the measures of two angles is 180 degrees if and only if the two angles are supplementary. So notice, I got rid of the if and the then. They're gone now. I took the first part, put it here, took the second part, put it here, and put if and only if in the middle. That's all you're doing. Don't try and do extra. Give this one a try. Same thing. What I want you to do, check to see if the conditional and its converse are both true. Then, if they are, we can write it as a biconditional. So take a couple minutes, give this a try on your own, make sure you can. Okay, so tell me what's going on here. Is the converse true? if we look, we switch it around. If the angles are congruent, then two angles have equal measure. Is that true? Of course it is. That's what congruent means, right? Congruent means that the two things are identical. So if you've got this angle over here, this angle over here, and they're congruent, they're identical, that means that they have the exact same measure. So the statement is true, its converse is true, so we can write it as a biconditional. Two angles have equal measure if and only if, and I'm going to do the IFF, they are congruent. And that's true for any angle, any segment, because when you go through, you look at the piece. If the two pieces are identical, they measure the same, right? If you've got two line segments, one of them's 5 inches, the other one's the same, so it also better be 5 inches. So now what we want to do, let's do the opposite. What are the two conditional statements that form this biconditional? So we're going to break it up. And here's the way I do it. I find where the if and only if is, and that tells me that's the separator. So I'm going to put parentheses around the one part, put parentheses around the other part. And then I can do if, then, right? And so if a ray is an angle bisector, then, so I put an if in front, then, and then the second part. It divides an angle into two congruent angles. There's the one. There's our original statement. And then the converse. Again, we're just going to flip them around. If what? If a ray divides an angle into two congruent angles, then, don't forget I do an if, comma, then, right? The ray is an angle bisector. Okay, so it's just breaking it up. So we're going to go ahead, we're going to give this a try ourselves. So I want to know, what are the two conditionals that make up this one? Make sure that you are capable of doing it. All right, let's look. Once again, all we're doing, take this part right here. And here's your first part. Here's your second part. And we're going to do the two if-then statements. Our one going forward is this one. If two numbers are reciprocals, then their product is 1. That is to say, so reciprocals, remember, we're thinking about like 2 over 1 versus 1 over 2, 4 over 3 versus 3 over 4, right? And if two numbers are reciprocals, their product, when you multiply them together, the result when you multiply them together is the product. Their product is 1. 4 times 3, 3 times 4, we get 12 over 12, right? which is 1. And we're going to go the opposite way now. We did the statement. Now let's do the converse. So the converse, we're looking at just switching it around. Start with if the product of two numbers is 1, then they are reciprocals. Right? So we've got that statement, we've got that converse, and we're good to go. That's what they wanted. What are the two conditionals? These two. So now let's get into talking about definitions. When we're talking about a definition, we have to be talking about something that can be written as a good and proper biconditional. Definitions should be clear. If you're using weasel words, if you're not using words that have a very, very, very specific meaning, if you're not using words that are precise, and if you're not using words that can be flipped around and be true in both directions, then your definition is going to be bad, right? So let's talk about these. Is this definition reversible? If yes, we're going to write it as a true biconditional, and if not, we're going to say why. So look, here is what we have. A quadrilateral is a polygon with 4 sides. Okay, well, the way that it's written, it's difficult to work with. Why don't we do like we did last time? Separate it out into the subject and the predicate. And then let's write it out as our statements. If a shape is a quadrilateral, then it's a polygon with 4 sides. Yeah, right? Shape is a quadrilateral, then it's a polygon with 4 sides. Well, that's true, right? Quadrilateral means 4 sides, so we're good here. Let's write it the other way. If a polygon has 4 sides, then it's a quadrilateral. Isn't that right? 4 sides means quadrilateral. So we know this is true in both directions. So we can write our biconditional. A shape is a quadrilateral if and only if, I'm going to do the IFF, it has 4 sides. Notice, all of these words here are very specific. Quadrilateral, polygon, 4 sides, right? Very simple to write, very easy to understand. Where things get difficult is when we have non-mathematical definitions. Those are more difficult. But let's try and keep with mathematical definitions for this one. Does this definition work? Write it as a biconditional if it does. So is it can it be rewritten as a true biconditional? Is it a good definition? Absolutely. Here's our original conditional. If then, so if the angle is straight, then it measures 180. The converse, let's look at that one. If an angle measures 180 degrees, then it's straight. Yeah, also, because again, these are our definitions that we have, right? These are what we were taught. So now we can write it as a biconditional. An angle is straight if and only if it measures 180 degrees. All right. Last one. Here I have a bunch of statements, and I want to know if these are good definitions. So let me kind of move some of these out the way a little bit so that we've got enough room to work. Move these over here. So a square is a figure with 4 right angles. That is true, right? But is a square the only figure with 4 right angles? No. And this is the problem. This is not specific enough. It's got to have 4 right angles. It's got to have 4 equal sides. Even though this could describe a square, a rectangle, one that's not a square, this is a great counterexample, right? So this one, not a good definition. All right, well, not a good definition. No. How about this one? A fish is an animal that swims. Well, it is true that a fish swims, but remember, a definition has to exactly describe. A fish is an animal that swims, but are all animals that swim fish? What about a whale? Or a dolphin? Or an otter? Or a seal? Or a squid? Well, squid's a fish, right? There are lots of things that swim that are not fish. So that doesn't work either. How about this one? A penny is a coin worth 1 cent. Yeah, that works, right? Now, the key here is we're talking about the word cent. A cent only has meaning in American currency, right? So this no other thing that is worth 1 cent exists besides a penny. Right? We don't have to worry about other countries that have other denominations. Like we don't have to worry about considering the peseta or the ruble or the franc or the euro, because the cent tells us everything that we need to know. So a penny is a coin worth 1 cent. That is a good definition. Let's look at our next one. Rectangles have 4 corners. Well, that is true, but there are plenty of other things that have 4 corners, right? I could draw lots of different things with 4 corners, some of which are rectangles, some of which aren't, right? 1, 2, 3, 4 corners, definitely not a rectangle, right? So just like up here, it's not specific enough. If it said rectangles have 4 right corners, 4 right-angled corners, then yeah, sure, we could go with that, but they're not specific enough. And then last one, giraffes are animals with very long necks. Well, so yes, one of the things that we know about a giraffe is that it has a long neck. But once again, giraffes aren't the only animals that have long necks. Think about ostriches and emus, and what else has a really long neck? I'm sure there are more animals with long necks than what I can think of right now besides the ostrich and the emu. But again, this is not good enough. Even if it was giraffes are mammals with very long necks. Are there other mammals that have long necks? How long does it have to be for it to count as what we would want for a giraffe? Just words like very long are not good enough. You know, it's difficult to come out with something like that when they don't give specific information. I was talking about weasel words before, very long. Those are weasel words. You're not telling me exactly. You're not giving me any sort of real consistent idea as to what you actually mean by the size there. So this one also is a bad definition.